Hello YouTubers, this is Ron, aka Bill7974, and today I want to talk about DragItAnywhere.com, the DIA unit, and the sensors. And as you can see, and as I mentioned in the other videos, these others are blocked off because I don't use them. But standard phone jack for some of these. Always goes, the little tang on the bottom goes always on the bottom. And when you put it in, it may not keep, so you may have to use your finger on the bottom to keep it from coming out, and it'll snap right into place. No problem. Okay, for the sensors, Todd uses the 4CP, 4P like a phone jack, and make sure all the connections, when you look at your DIA unit, that little clippy guy, all of them will be put into the bottom. These are 6C, 6P, and he has used these for the tree connection to the DIA unit and also for the display unit. This is our Christmas tree, our very valuable Christmas tree. And Todd used the RJ45 for left and right lane plugged into the DIA tree shield. This is my in-house test board. And one of the reasons I've made this video is because my track is a little unorthodox. It's 3/4 of an inch thick or close to it. And the sensors are mounted really deep. So in order for the photoresistors to really work, I'm going to need some good lighting to make sure that they are working properly. We'll flip this thing over and see what we got. Of course, everything is in reverse. And I just made a note for myself. Pre-stage has a drop of white out on it. Pre-stage, so that's just for me. Now yours may be different. You may have different sensors. Todd has done something for me here. I want to go ahead and show you. See that greenish line on every one goes to the terminal on the end over here. Every one like that. Now, of course, it's opposite here because it's on the opposite side. So if you ever have to replace these, make sure they're on the right side. I found out on the pre-stage and the stage, while using it, I've had to set the module, the potentiometer here, and they go about 3/4 from left to right. And I had to set them from the left side about 1/4 way, and that made them work properly. Now, on true, the finish line sensor would just set just a little over halfway. Now yours may be different. Everyone's different. Set it accordingly. Okay, let's get started. We'll go ahead and plug it in. Everything comes on. It's doing self-checks. And you go through it. To get started, you go through the whole system. Drag, 2 people, Pro Stock. This time I changed it to a 500 light because doing the filming and doing this and doing that, I just left it at 500. 4 was just too quick for me. Configuration, bracket, bracket, no. Yeah, everything remains the same if you looked at my last video. Save the configuration, yes. Okay, left and right lane, get ready. Now if you press the auto, it'll automatically start your game. So we're ready. All we need to do is start our cars, which we'll go ahead and use a piece of balsa wood to simulate our pre-stage, stage, and finish. But take a look underneath. You can see the LED lights from the sensors. They're working. Got no sensor alarm. We'll start. Pre-stage, stage, Date. It says go. Oh, it says right lane wins. 3 point, ET, speed 742. RT 343. Whatever. Okay, let's take a look at things. And we'll hit the auto here. Oh, it says get ready again. Went along with our simulation, what I'd done is to move the light source further away at the head of the track, and actually disconnected the right lane sensor, and as you can see, aligned sensors 4 and 4, both 4 and 4, left and right finish line sensors. Well, you got two problems. The light source. If we move the light source back, oh, look at that. Oh, it changed. Now, just our right lane. Well, what happened? I think the 2-year-old or the 72-year-old got in there and knocked it loose. We better check everything underneath, make sure everything's copostatic. So what we're going to go ahead and do is realign that and make sure you pay attention to that green line there. Goes down on the right-hand side. Let's take a look at that sensor. Let me plug it in first. Power it up, and as you can see, when you first initially turn it on, you're going to have your LED on the top turn on. The same for both sides and all the finish lines too. Other problems might be, make sure you have the good light source there. Make sure these are properly in. As you can see, it was very easy to pull that out. Let's put it back in. Okay. All right. And your potentiometer, make sure everything is copostatic there. Let me tell you a little story here. When I was putting my finish line sensors in underneath the normal slot car drag track, I got to do it upside down and turn around. You're upside down. You can't think right. You're just, So I got confused. I looked away for a second, and I actually, when I was trying to screw the screw in, I actually busted off one of these tips on these LEDs. Well, it quit working. So the DIA unit would not clear. And after carefully looking at it, I contacted Todd. He said, send it back and or else we'll just give you a new one. Okay, fine. Well, it was a problem, and he replaced it, and he also gave me another free replacement. Well, thank you, Todd, the owner of dragitanywhere.com. Well, they're strong and durable, except when it comes to a gearhead like me. I'll ruin it for sure. Anyway, there is your photoresistor on the opposite side. This is my replacement. You have your potentiometer. Okay, take a real good picture of this next picture. Here's the connector with that green line Todd had made, and that will go on this side, power LED plus, and then on the other side, well, you have the ground right in the middle. And you have this side over here, LED, DO LED, positive. A photoresistor light detection module, also known as a light independent resistor LDR module, detects changes in light levels by measuring the resistance of a photoresistor. The photoresistor is a passive component made of high resistance semiconductor that exhibits photoconductivity, meaning its resistance decreases when light hits its sensitive surface. The amount of resistance generated depends on the intensity of the light, and with the higher light intensities causing lower resistance and lower light intensities causes higher resistance. A photoresistor module includes the LDR and other components that allow to interface with a microcontroller like Arduino or ESP32. Photoresistors are commonly used in circuits that need to respond to changes in light conditions, such as night lights, solar trackers, and alarms. Oh, slot car drag racing tracks. Slot car tracks. For example, you can use code blocks to listen to the state of the photoresistor and set an LED's brightness based on how much light the sensor detects. There you have it. One thing I forgot to mention is the photosensitive sensor module with an adjustable potentiometer. We talked about that earlier, which can adjust the brightness of the light detected. There you have it. You can find out a lot more about these photoresistor light detection modules online, and there's a lot on YouTube. Go ahead, take a look. If you can't find what you're looking for, contact Todd at dragitanywhere.com. He'd be pleased to talk to you. And to finish this short video, I just wanted to say the main DIA unit, as shown here, is a powerful standalone microprocessor. Todd at dragitanywhere.com has a strong passion for what he does. So if you like slot car drag racing or slot car lap racing, don't just sit idle and watch. Go out and build your track. Thanks so much for watching, YouTubers. Have a great day.